Hello everyone, today we will see what is the difference between eigenvalues versus singular values. First, in eigenvalue, if you look at the shape of the matrix, the shape, it always a square matrix. Say A is equal to 1, 2, 3, 4. You cannot find eigenvalues for any rectangular matrix. So always to find eigenvalues, the matrix should be square. On the other hand, for singular values, you can find singular values from any shape, like square, or you can say rectangular. So you can find singular values for matrices like, say, A is equal to 1, 2, 3, 4. Say B is equal to 2, 3, 4, 5, 6, 7. So this is a rectangular matrix. So you can find singular values for rectangular matrices as well. But you cannot find eigenvalues from the matrix like rectangular. Okay, the next one, and one of the major one, is that in eigenvalue, the values should always be positive, it would be negative, and it also can be zero. So eigenvalues can be positive, can be negative, and can be zero. On the other hand, singular values always positive, and it can also be zero, but it cannot negative. So it cannot be anytime negative, so it can positive or zero. And the last one is the interpretation. Exactly, if you ask me what is eigenvalues are, see, and it is the most important differentiate between eigenvalues and singular values, is that without rotation, how the matrix scales vectors to a spatial direction. So suppose I have a matrix which contains two vectors v1 and v2, and from this matrix we extract an eigenvector, some eigenvectors. Say you extract one eigenvector like this one and one like this one, and this is the biggest one, and this eigenvector is scaled up. So without any rotation, we first of all find from a matrix, or we can extract from a matrix, eigenvectors, scaled eigenvectors, and without rotation. Now, what is the meaning of the rotation? You will understand very much easily from in this part of the singular values, that with rotation, how the matrix scales or stretches vectors to spatial direction. So now suppose I have two vectors v1 and v2, and these two vectors creates a matrix, and from that matrix if we extract the singular values, it will be very much like, say, this one and say this one. Now to find this singular vector, it's a singular vector, we cannot directly find this singular vector at once. First we found something like this one is the first stage, and this is the second stage. And how this second stage okay, so how from the first stage we turn into second stage? By rotation. And that's why we write it with rotation, how much the matrix scale or stretches. We stretch this vector, that's why we stretches or scales vectors to a spatial direction. So in the case of eigenvalues, we never rotate. At very first, in first stage, we get our spatial vector, which is eigenvector, and which gives us eigenvalue. So basically that is the basic and major differences between eigenvalues and singular values. Thank you very much.